नमस्कार मित्रांनो, मागच्या वेळेला आपण सुरुवातीला आपल्या फिजिक्स BSc फर्स्ट इयर आणि मेकॅनिक्स प्रॉपर्टीज ऑफ मॅटर अँड साऊंड याच्याविषयीच्या असणाऱ्या फर्स्ट इयरच्या फर्स्ट सेमिस्टरच्या अभ्यासक्रमाची चर्चा केली. त्यानंतर आपण पेंडुलम्स बघितले आणि हेही बघितलं जे सिंपल पेंडुलम जो तुम्ही 11वी-12वीला अभ्यासला असेल त्या अभ्यासानुसार सिंपल पेंडुलम इज नथिंग बट अ पॉइंट मास suspended to a rigid support by means of a weightless and inextensible string. ही त्याची डेफिनेशन. परंतु ॲक्च्युअल प्रॅक्टिसमध्ये होतं काय, देर आर सम ड्रॉबॅक्स. means that we cannot take a point mass. Again, another thing, we doesn't have inextensible string, and due to these types of drawbacks, the inventors have been invented to find out the acceleration due to gravity, another pendulum, and that is nothing a bar pendulum. Again, we have discussed these things also, that bar pendulum is nothing but a metallic strip, and holes are drilled over that strip on an equidistant, and it is supported to a rigid support, and by giving oscillations, for certain oscillations we have to find out the time period, and by which we are getting the acceleration due to gravity. But again, there was a problem, because when we goes to drill, at that time the drill is not perfectly perpendicular to the plane of the paper, due to which that pendulum wobbles, and therefore we are not getting a perfect oscillations. Therefore, again, to overcome these problems, there was another one type of compound pendulum, and that is nothing but a Cater's pendulum. See, in this Cater's pendulum we have seen the construction and how it works. We also been deducted the formula to find out that acceleration due to gravity. Again, the next in this chapter means this part, compound pendulum, equation for it, time period, then interchangeability of center of suspension and center of oscillation. Means that if we have been changed the center of suspension to center of oscillation, and oscillation to and if we have been find out the time period for it, it is equal, and therefore the next, that is a Cater's pendulum. All these 3 to 4 points are nothing but is concerned with the acceleration due to gravity. The another next part, it is nothing but we have to see the same from this chapter, but it comes under the gravitation, and therefore for the gravitation, Newton's law of gravitation is the important one. See, again, in concern with this Newton's law of gravitation, in junior college study, particularly from the physics subject, you have been gone through this Newton's law of gravitation. मागच्या वेळेला सुद्धा आपली याच्या संदर्भात जी चर्चा झाली की बाबा आपण 11वी आणि 12वी या दोनही वर्गात जो फिजिक्सचा अभ्यास केला असेल त्याचे जे काही पुस्तक असतील, त्याच्या नोट्स असतील, ते आपल्याला आता काढून ठेवायचे आहे आणि ते आपल्याला बघायचे आहे मधून. कारण तो बेस ह्या पुढच्या सगळ्या वर्गांचा आहे. अँड देअरफॉर this Newton's law of gravitation, its a statement is very simple. As per this statement of Newton's law of gravitation, simple one, this says that every particle of matter in the universe attracts every other particle with a force and which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This is the simple statement. Means what? He says that we are familiar with the scientist Newton, the name Newton, who have been done much more work in the field of acceleration due to gravity, in the field of gravitation, in Newton's law of cooling, number of laws. See, particularly for the Newton's law of gravitation, for it, it's a statement. He says that every particle of matter in the universe, which is situated in the universe, one particle attracted by the other particle and with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, see, as per the statement, we will consider the M1 and M2. M1 and M2. These are the two masses of two particles. Two particles. And the distance between them, see here, this is a M1 and this is a M2. Distance between them, what will be the distance between them? Distance between them is R. As per the definition, what he says that if there are two particles, they attracts to each, one particle is attracted by the other particle with a force which is directly proportional to the square of the distance between them. Means that F is the force, F is the directly proportional, here is the directly proportional to the product of their masses, that is M1 into M2, product of their masses, and inversely proportional to the square of the distance. Means R is the distance, square of the distance is R square. And therefore, we can write here F equal to G into M1 into M2 divided by R square. See here, G. What is meant by G? G is nothing but the universal gravitational constant And in another form we can have here, if m1 and m2 if see m1 mass of this particle is m1, and if it is equal to m2 and these both masses are unit 1, that is 1, then the equation 1, this equation we can say this is the equation number 1, and this equation becomes, see, m1 m2 is if 1, and then the equation 1 is nothing but f equal to g. Therefore, and see, along this m1 equal to m2 equal to 1, and again r equal to 1. R means distance between them is also equal to 1. Then if this whole is 1, then f equal to g. And see, the gravitational constant is equals to the force of attraction between the two masses of matter with unit separation. And see, the another part, whenever we studies in physics, for any type of quantity there are dimensions. The concept of dimension is important one, and therefore the dimension of gravitational constant, is nothing but is equal to, see, m, l and t. M for mass, length and time. M is -1, L is 3 and T is -2. These are the dimensions. And for this universal gravitational constant, what is the numerical value? Universally accepted, we have to see. See, the universal gravitational constant value is nothing but 6.67 multiplied by 10 raised to minus 11 Newton meter square and per kg square. हे बघा, तर हे सगळं झालं अबाउट न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन. नाउ if this is a Newton's law of gravitation, if there is a presence of gravitation force of attraction, then there should be a gravitational field. Therefore, the next is nothing but a gravitational field. Gravitational field. See, there is a, whatever be the existence of a matter, there is a field. Means, if we have been having a ceiling fan in our hall or a room, there is also it's a field. Means that up to which point we are getting the air, that up to that point is its field. Therefore, the space around a body, a space, we will consider a body here, and the space around a body within which its gravitational force of attraction can be experienced is called the gravitational field of the body. Very simple one. See the space. This is a space around a body within its gravitational force of attraction can be experienced is called the gravitational field of the body. See the another term, gravitational field intensity. The gravitational field intensity again it is denoted by the letter E. Or we can say in another word, the intensity of a gravitational field. Now again, for explaining the gravitational field intensity or the intensity of a gravitational field at a point inside the gravitational field, या ग्रॅव्हिटेशनल फील्डच्या मध्ये जर तो एखादा पॉइंट असेल, then a body is a force experienced in a unit mass placed at that point. See once again, हे परत एकदा बघूया. The gravitational field intensity at a point inside a gravitational field of a body is a force experienced in a unit mass placed at that point. Therefore, commonly here we can say that the intensity of a gravitational field at that point and the intensity of the gravitational field at a distance r from point mass m is denoted by, here this intensity E is denoted by G into m upon r square. G is nothing but the gravitational constant, m is the mass of the body, and r is the distance, square of the distance. And by taking its derivative, E equals to minus of dV by dr. From this equation, intensity of gravitational field at any point in this field equal to the rate of change of gravitational potential gradient at that point, where dV is the small change of gravitational potential for a small distance r. This is the definition for it. Now see, firstly we have been discussed about the Newton's law of gravitation, then gravitational field, then gravitational intensity. Now the another concept is gravitational potential. Now we will see the gravitational potential. See, all these terminologies we have to use in this chapter for deriving the different equations, and therefore one should know about all these things. See now, gravitational potential. Potential in our common language we can say strength. Now here the gravitational potential is the amount of work done in moving a unit mass from infinity to a point inside the gravitational field of a body. See here, we can see that this is a body having a mass m, and here a point mass q, and from this is a point P now. See, as per the definition, gravitational potential is the amount of work done in moving a unit mass, this unit mass from Q to P. It is moved, and through a distance from infinity to a point inside the gravitational field. And see here, this is at in r is the distance. It is moved through dr. See once again, gravitational potential is the amount of work done in moving a unit mass from infinity to a point inside the gravitational field of a body. Now here we have been considered the gravitational potential due to a point mass, and here we are considering a point P at a distance r. This is a point P at a distance r from the particle mass m. This is a particle having a mass m, and for see force experienced by the unit mass, the force experienced by the unit mass at P is given by F equals to, we know the Newton's law of gravitation, and by that law F equal to G mass m distance square of the distance between them is r square. This is equation 1. It is directed from P to M. It is directed from P to M. It is due. And work done म्हणजे P पॉइंट पासून M पॉइंट पर्यंत जे वर्क डन करावं लागलं त्याला आणायला, वर्क डन इन मूविंग द युनिट मास थ्रू द डिस्टन्स dr. या हे dr डिस्टन्स ट्रॅव्हल केलं त्याने, dr to the point Q, that is the difference of potential between P and Q. P आणि Q मधला हा difference या potential मधला, that is nothing but dV equal to G into M R square, M by R square into dr. This is the second equation, we get it. Therefore, now we will calculate the potential at P. Potential at this point P due to the unit mass. Potential at P due to unit mass through the integration we will see V is nothing but equals to integral of Gm by r square into dr between the limit r to infinity. And therefore, by solving this integral, we get here V equals to potential, gravitational potential V equals to Gm and in bracket 1 by r square is nothing but Gm in bracket 1 by infinity minus 1 by r, and therefore here V equals to positive quantity, no problem, Gm 1 by infinity 0 and minus 1 by r, and this is nothing but V equals to minus of minus sign. How it comes you will get by solving this Gm divided by r. This is the important gravitational potential, and it is nothing but a negative quantity. Its maximum value is 0 at infinity. मित्रांनो, आपण यात ज्या टर्मिनॉलॉजीज बघितल्या त्या आपल्याला पुढचा भाग जेव्हा आपण शिकू पुढच्या वेळेला तेव्हा तितकाच महत्त्वाचा आहे, आणि त्याच्यामुळे त्याच्यावर थोडंसं वी हॅव टू कॉन्सन्ट्रेट ऑन इट. Means Newton's law of gravitation, then gravitational field, then gravitational potential, and gravitational field intensity. These are the things. Okay, thank you.